Okay, enough about fairy floss. Okay, quadratics are used to apply several practical solutions too. A ball is thrown in the air. Its height, h, soz. Yeah. Okay. Kelson, Surly, you'll probably need to sit up so you can actually see. Okay? Okay. A ball is thrown in the air. A ball. She can barely sit on the chair and see. It's tempting. I was thinking about bringing in one of the high chairs from home, but if I still taught the year sevens, I'd probably bring in the high chair because there's a couple in there that need it. Trouble is, once they're in year 9, they're taller than me. It's depressing. Sorry? Oh, year 8, Geordie. Needs a ladder. I'd call him an ankle biter, but he'd need a ladder to bite my ankles. Geordie. No more short jokes. We've only got a little time. Okay. I know, Lachlan Cole's taller than me. And he's D5. All right, so. Ball. Ball. A ball is thrown in the air. Okay. Oi. Ball is thrown in the air. Its height after t seconds can be given by the formula height equals 20t minus 5t squared. Okay, so a ball is thrown in the air, its height. Now it's not going forward, it's just measuring its height over time. Okay, we need to graph the function to calculate the maximum height the ball will reach. Okay, it's not actually that difficult, and it doesn't matter what the practical problem is, you're still going to do it the same way we've done it. You have a formula, you have some values, you're going to substitute in. So first one, 0. 20 times 0 is 0, minus 5 times 0 squared is going to be 0. Funnily enough, after time 0, the height of the ball is 0. Should not be too much of a surprise. Okay, so now 1. So we've got 20 times 1 is 20, minus 5 times 1 squared. Everyone happy with that being 15? Next one, 20 times t is 40, minus 5 times t squared. 40 minus 20 will give you 20. 60 minus 45 will give you 15. 80 minus 80 will give you 80. Oh, what? T squared 16, 80, yes, it will. It's 0. 80 minus 80. I was trying to do 5t squared, and 4 squared is 16. 5 16s are 80. Okay, next one, what is it? You reckon it's negative 15? Okay, let's have a look. 20 times 5 is 100. Minus 5 times t squared. T squared will be 25. 5 times 25 is 125. 100 minus 125 will give you minus 25. Don't forget, it's going to accelerate. So it's going to start getting further and further. So if you have a look, like between 1, 2, and 3, there's only 5 either side of it. Before that, there's 15. Next one, there's 25. It's starting to accelerate. Okay, so we've now got our points. We now need to plot them. So our first one is 0, 0. Very handy. Next one is 115, which is about there. Next one is 220, which is there. 315, 4, 0, and 5 minus 25, which will be down here somewhere. Oh, that was terrible. And off it goes down into the distance. Is everyone happy with that? Yeah, okay. Now this is a concave down or a sad face 1. It's got a negative in front of the 5, in front of the t squared. Can you tell me, is this going to have a maximum or a minimum, Surly? Cool. What is the maximum height the ball reaches? 20. At what time does it reach that maximum? After how many seconds? 2 seconds. Excellent. So you're actually able to read that. Now, if you didn't have the table of values, you should still be able to read it off the graph. Well, this is interesting. Why can't it? Because we've drawn it. Excellent. Well done. No, it's perfectly legitimate. What you've done is just realize one of the practical problems. When you're doing a practical problem, we can say that if we were doing the parabola and it wasn't to do with actual ball going up and down, that it would go to minus 25. But realistically, does the minus 25 make any sense? Because once it hits ground zero, it won't go any further. Everyone happy with that? Everyone happy with that?